Hello friends, in this lecture we will study about the concept of moment and couples. So what is moment of a force? So we can say that it is a turning effect that is produced by a force on a body is known as the moment of force, and we can define as a moment P is equals to M is equals to P into L, where P is a force acting on a body and L is the perpendicular distance between the point about which the moment is required at the line of action of the force. So it is the fundamental definitions of the moment of a force. Now, if we are representing this moment in the graphical way, we can see that point P, that is the force, is acting at along the line AC, and for this one we have to find the moment. So graphically we can look in this figure. So moment of the force P, moment of the force about P, moment of the force about O, we can write here P into OC. P is the force and OC is the perpendicular distance. Here perpendicular distance is OC and P is along the AB. So finally we can write here AB into OC, that is equal to 2 into area of the triangle ABO. ABO we can see from this figure. So we can graphically represent in this way. So now after that we have to learn about the sign convention of the moment. So in this figure we can observe that force is acting at the multiple ends, and if we have to consider the moment about a point O where the multiple forces are acting at the other ends. So with respect to the first force we can write here P into O, that will be in the clockwise direction, and according to the sign convention we can take the clockwise direction as a positive sign. Similarly, if we are talking about the anti-clockwise moment, है ना, in the anti-clockwise moment, so if the forces are acting opposite to the point O, and if we are apply the force, अगर हम इस force को apply करेंगे तो क्या होगा, ये anti-clockwise direction में rotate करने की एंटी क्लॉकवाइज डायरेक्शन में रोटेट करने की कोशिश करेगा, तो ये आपका एंटी क्लॉकवाइज मोमेंट होगा, और इसको हम लोग नेगेटिव साइन से हम लोग रिप्रेजेंट करते हैं, नेगेटिव साइन से आपको रिप्रेजेंट करने के लिए एंटी क्लॉकवाइज मोमेंट को यूज करते हैं. Now further, it is the moment of a force which affect is turn or rotate the body about the point in the same direction in which hand of a clock move. Is known as the clockwise movement. We can define like this way. And similarly, what about the anti-clockwise movement? So it is the moment of a force. It is a moment of a force which affect is to turn or rotate the body about the point in the opposite direction in which the hands of the clock movement means आपका जब भी पॉजिटिव और क्लॉकवाइज डायरेक्शन में मूवमेंट होगा, रोटेशन होगा, तो आपका पॉजिटिव मोमेंट होगा, क्लॉकवाइज मोमेंट होगा, और आपका एंटी क्लॉकवाइज मोमेंट होगा, तो उसको लोग नेगेटिव साइन से रिप्रेजेंट करते हैं. ठीक है. Now what about the Varignon principle of moment, or we can say that it is also known as the law of moment. So if a number of coplanar forces are acting simultaneously on a particle, the algebraic sum of the moment of all the forces about any point is known as the moment about any point is equal to the moment of their resultant force about the same point. है ना? So we can say that if a number of coplanar forces are acting simultaneously on a particle, the algebraic sum of the moment of all the forces about any point is equal to the moment of their resultant force about the same point. So based on this concept, let us do some numerical. So in this, the problem statement is 15 Newton force is applied perpendicular to the 0.8 meter wide door edge as shown in the figure. Here, in this figure, 15 Newton force is acting at a distance of 0.8. Find the force of moment that depends on the joint if this force is applied at 60-degree angle to the edge of same door as shown in the figure. So find the moment of this force. इस केस में हमें मोमेंट का वैल्यू फाइंड करना है जब आपका फोर्स 15 न्यूटन वन एंड पे एक्ट करता है और दूसरे एंड पे इसको हमने हिंज कर दिया है, इसको हमने फिक्स कर दिया है. सेकंड केस में उसी प्रॉब्लम के लिए हम लोग 60 डिग्री एंगल पे आपका एक फोर्स अप्लाई हो रहा है, तो इसके लिए भी हमें एक मोमेंट फाइंड करना पड़ेगा. सो 15 न्यूटन का फोर्स आपका गिवन है, और आप इसके लिए जब हम फोर्स इंटू परपेंडिकुलर डिस्टेंस की बात करेंगे तो आपका मोमेंट आएगा. तो यहाँ पे फोर्स 15 है, P इंटू एल, P इज द फोर्स, L इज द distance. P into 15 into 0.8 we can write here 12 Newton meter. now in the second case, if the force is acting at an angle of 60 degree, तो आप वहां से इस एंड पे जब आपका फोर्स लगेगा तो इसको हम लोग दो कंपोनेंट में डिसॉल्व करेंगे। दो कंपोनेंट में डिसॉल्व करने के बाद आपका जो हॉरिजॉन्टल कंपोनेंट में फोर्स एक्ट करेगा दैट इज 15 cos 60 डिग्री, एंड इन द वर्टिकल कंपोनेंट इट विल बी 15 sin 60 डिग्री। So along the vertical component we have to find the moment, because only we have to consider the perpendicular length, perpendicular force and the length. So when the forces is acting 60 degree, uh, we can write here 15 sin 60 degree into 0.8. So after calculating this value, we will get the result of moment. So after calculating, we will get the value of moment is equal to 10.4 Newton meter, है ना। So इसके basis पे we will do another numerical. So in this figure we can see that a uniform plank of 30 meters, 30 Newton, a uniform plank of 30 Newton and 2 meter in length ABC, है ना। ABC आपका length है, is supported at one end at point A and B at point A at a distance of 1.4 मीटर। यहाँ पे जो पॉइंट बी है आपका 1.4 के डिस्टेंस पे अवेलेबल है। पॉइंट ए जो है आपका पॉइंट ए इज पॉइंट ए इज 1 मीटर। No, so from the figure, the maximum weight W that can be placed on C so that the plank does not roll over. So here we have to find the resultant and moment of this condition. So here 30 into zero point 0.4, 30 is the weight and zero point 0.4 is the distance. If we are looking in this figure, 1.4 is the total distance. So we have to find the moment along the point A, along the point A. So here 30 into zero point 0.4 is equal to W into zero point 0.6. So from there we can easily calculate the value for the W weight, that is equal to 30 into zero point 0.4 by zero point 0.6, that is equal to 20 Newton. That will be the answer of this question. Similarly, we will do the another numerical. Here the problem statement is three forces of 2p, 3p and 4p act along the three sides of an equilateral triangle of side 100 mm taken in order. So for this case, we have to find the magnitude and position of the resultant force. So again, we will resolve all the components in the horizontal and vertical direction. So here we can see that 2p, 2p load is acting at an angle at the point C in the horizontal direction. Again, if you are observing at the point A, 3p force is acting at the 120 degree along to the x-axis. It is the 3p cost 120 plus 4p load is acting at the point B. So horizontal component will be 4p cos 240 degree. So after putting the value of cos 120 and 240 in that equation, we will get the summation of horizontal component, that is equal to minus 1.5p. राइट। अब हम उसके बाद वर्टिकल कंपोनेंट के जो है फोर्सेस उसको हम रिजॉल्व करेंगे। तो अगेन वी विल टेक द रेफरेंस ऑफ द सेम फिगर। सो 3p sin 60 डिग्री माइनस 4p sin 60 डिग्री, हम इन दोनों कंपोनेंट को रिजॉल्व करेंगे हॉरिजॉन्टल एंड वर्टिकल डायरेक्शन में। एट द पॉइंट ए, एट द पॉइंट ए 3p cos 3p sin 60 degree is the vertical component of this force, minus at the point P or the point B we will get the 4p sin 60 degree along the vertical direction. So after that we will put the value of sin 60 degree, that is equal to point at 0.866 and sin 60 degree का value put करेंगे, and after putting the value we will get the vertical component, vertical summation of vertical component is equal to minus 0.866p. Now after getting the value, we have to find the resultant. So we will square all the components in the horizontal direction and the vertical direction, that will be under root minus 1.5p whole square. And in the vertical direction, the value is minus zero point 0.8 into minus 0.866p whole square. So after solving this one, we will get the value of resultant is equal to 1.732p. Now after finding the resultant, we have to find the moment. So we have to consider one of the vertical component. So if we are considering the vertical component, we can see that 3p into sin 60 degree and the angle is and the length is 100 mm. So we will multiply this term with the 100, and that will be equal to the resultant of the vertical resultant, that is equal to 1.732p into x. X is the distance. So after solving this one, we will get the value of the x is equal to 150 mm. So I hope that you all have understood the content of the today's lecture. Remaining some more problem is there, so you can do by yourself and find the results. So similar way you can also get the another. You can also find the also solve the numericals based on this concept. So I hope that you all have understood the content of the today's lecture. Further, we will come with the new topic. Thank you.